Lesson 27, the binomial probability distribution. Example 8. If someone were to bet $1 on red in the game of roulette 40 separate times, what is the chance that they would end up with a profit? So here we're trying to answer a question about what is the chance that this occurs. The chance is just another way of asking for a probability. So to find this probability, we focus on this random process, which is betting $1 on red. Well, this follows a binomial random process, since a bet on red in the game of roulette will result in either a win or a loss. That is, two possible outcomes. So we can use the binomial probability distribution to find this chance. But in order to use the binomial probability distribution, we need to know the value of the three variables, n, p, and x, where n represents the total number of attempts. Well, in this case, this person was to bet $1 on red in the game of roulette 40 separate times. Thus, there are 40 total bets being placed. So n would equal 40 for this problem. Now p. P is the probability that it results in this particular outcome every time this process is repeated. In this case, the outcome is referring to winning a bet. So when you bet $1 on red, the probability that you win this bet is if the marble randomly lands in one of the red colored slots. So since there are only 18 slots out of a total of 38 slots on the roulette wheel that are red, you have 18 ways of winning out of the 38 total possibilities. So P would equal 18 out of 38. Now the value of the random variable x is based on the question we're trying to answer. So here we want to know the chance that they would end up with a profit. So now we need to find the value of the random variable x that corresponds to them ending up with a profit. Well, to end up with a profit, they must win more money than they lose. Since betting on red in the game of roulette is an even money bet, they must win more than half of these bets to end up with a profit. Thus, the value of the random variable x that corresponds to ending up with a profit would be the x greater than 20. So in a binomial, the random variable x is discrete because it's a count or a frequency and can take on values anywhere as low as 0 to a high of n, in this case 40. The value of the random variable x, which are greater than 20, would be the values of 21, 22, 23, all the way up through the total n of 40. So now we can calculate our chance using our binomial probability formula with n equals 40, p equals 18 out of 38, and the x being greater than 20. So the probability of ending up with a profit is equal to the probability that the random variable x is greater than 20, can be found using the binomial commands on the calculator. But the binom PDF command only calculates the probability of exactly equaling the 1x value that's entered into the calculator. And the binom CDF command only calculates the probability of less than or equal to the value of the random variable x that's inputted into the calculator. It does not calculate the probability of x greater than 20. So probabilities of less than or equal to are opposite of probabilities being greater than. So we can use the binom CDF command here to calculate the probability of being less than or equal to, but it is the opposite of what we want, the probability of being greater than the 20. So we can use our rule for the not probabilities. The probability that you end up with a profit is equal to 1 minus the probability you don't end up with a profit. In this case, 1 minus the probability of x being less than or equal to 20. And the binom CDF command on the calculator can find this probability of x being less than or equal to 20. So on the calculator, we can take 1 and subtract the binom CDF command using n equals 40, p equals the 18 out of 38, and the x equaling 20. So on the calculator, we would go 1, subtract, and then second, distr, to get to the binom CDF command. Press enter to select, enter in the 40, comma, the 18 divided by 38, comma, 20, close parenthesis, enter. And here's our chance. Rounding to 3 places after the decimal, we get 0.311 for our result. Thus, the probability they end up with a profit is equal to 0.311 decimal. So, if someone were to bet $1 on red in the game of roulette 40 separate times, there is a 31.1% chance that they would end up with a profit.